We love our 3D printers, whether it's the SV08 or one of Sovol's bat slingers, or maybe even from another company. They let us create almost anything, as long as it's made of colored plastic. Toys, decorations, and my personal favorites, functional parts, but still out of hollow plastic. You're drawn to more natural materials: wood, leather, glass, ceramics, metals. I certainly was. But lasers, they seemed a bit messy. I had concerns about safety, fumes, reflected light, and honestly, we should all be cautious. After testing and working around these concerns with a few open frame laser engravers, I found a very affordable option that addressed all my worries and even made my 3D printer safer. Let me introduce you to my first enclosed CO2 laser, the Monport Onyx R55, where the R stands for revised in many ways, including a key feature that makes all the difference in my opinion. And as a bonus, stick around to see a complete mini project creating a personalized gift box for my family's favorite Danish crispy bed. I'm Gergo, and you're watching Gergo Print 3D, the YouTube channel for all things 3D printing and laser adventures. Check out the long list of my DIY projects, tutorials, and device reviews. Each comes with curated, translation-ready subtitles and detailed chapter markers for easy navigation. So, welcome. Now let's dive into what really caught my attention about the Monport Onyx R55. We've talked a lot about enclosures on my newly acquired 3D printers. Now this is a fully enclosed device as well. But unlike my 3D printers, this comes with a complete ventilation system. No need to take it outside like I do with my other lasers, and no extra hassle building my own enclosure. The protective window and safety sensors ensure we are protected from reflected laser light. With double the power of my strongest diode laser, it delivers lightning-fast cuts and deep 3D engraving, even into transparent materials like acrylic and glass. The built-in camera helps optimize material use, which minimizes waste, a feature that's really close to my heart. And the cherry on the top, the autofocus system, which the previous iteration didn't even have. This feature makes a big difference. Beyond convenience, it delivers sharper markings and faster, more efficient cuts. I'll explain more about this in the second half of the video. As usual, my device reviews start with unboxing and assembly. Most of my 3D printers and all diode lasers so far arrived in pieces, sometimes many pieces. But the Monport Onyx R comes fully assembled, packaged in a large crate. You just need an extra pair of hands to help lift it out of the box. At nearly a meter wide, it did take some planning to get it into my tiny studio, but now that it's in place, I have easy access to every port, control, and drawer on it. Plus, with its open bottom and the bench we put it on, there's almost no limitation on the height of the objects I can engrave with it. Since we already opened the device and removed the debris tray to show you the hole at the bottom, it's a perfect opportunity to explore some of the other internal components of this CO2 laser. The laser light source is this long glass tube filled with CO2 gas, which is protected from smoke by an aluminum cover at the back of the gantry. The gas mixture inside the tube gets excited by the current from this high voltage power supply located on the right side of the enclosure. This excites the molecules of the gas mixture, causing them to emit light. Don't ask me how it works exactly, I just read up on it. The light then travels through 3 adjustable mirrors, much like a childhood periscope, before being focused onto the work surface by a simple 10mm lens. We've also got a water cooling system to keep the gas at optimal operating temperature. The circulation pump and heatsink are housed on the left side, with the water colored green to make it easier to monitor the levels. Next to the controller board, back on the right side, we find the air assist pump, also built in. This pump pulls air from the outside through a hole at the bottom of the device and directs it through a nozzle in the laser head to keep the smoke out of the laser beam's path. It's amazing how they managed to fit all this tech in a simple, compact device like this. The Monport Onyx R uses linear rails on all axes, thick 12mm timing belts, and 3 synchronized 50mm tall stepper motors for the X and Y axes, which all contribute to a precise and robust motion system. Even the Z-axis is motorized with a 51mm range powered by a lead screw and also running on a linear rail. It has a clicky sensor to automatically probe material height. The venting system consists of several components. First, the air assist, then an exhaust fan in the back of the machine, and finally an external linear duct fan to make sure smoke and fumes are properly vented outside. Both the air assist pump and the exhaust fan kick in during active jobs. However, the external duct fan is independent, so it doesn't turn on automatically. While that's a slight inconvenience, it means I can use this duct and fan to vent fumes from my enclosed 3D printers as well. Look how I connected to my GDQ1 Pro. I will make a separate video on this topic a little bit later. And this takes us back to the debris tray and the 550 by 360mm honeycomb bed, both being removable for easy cleaning. Removing them also gives access to taller objects that can be placed under the machine, and the 360 by 7mm slots on the front and back allow for working with longer pieces. I haven't tested that yet. I plan to cover maintenance in a future video, but as you can see, everything is thoughtfully laid out and easy to access in here. Contrary to other reviewers, I had no issues with the length of the included cables. I used the longer USB cable for the camera and the included Ethernet cable for controlling the device. Setting up control via USB might be easier, but I opted to configure the default IP address 192.168.1.100 during installation, and both RD works and Lightburn connected seamlessly. While the device supports Wi-Fi, I could not find information on how to properly connect it to my network. The only way I managed was by connecting to the Onyx R's Wi-Fi host, but that meant losing internet access on my computer. Since the camera feed isn't accessible over Wi-Fi and only works through USB, keeping your computer nearby is still necessary. So I really don't see any reason for using Wi-Fi. Using RD-Works or Lightburn, we could send jobs to the laser cutter's internal memory. However, there's a single button on the device which only allows us to start and pause, resume the very last uploaded project without needing an active connection. There is no screen or other buttons on the device. And this brings us directly to the software side of things. Just like 3D printers run on Marlin or Clipper, simpler diode lasers use GRBL, while advanced CO2 lasers like this one run on the Ruida control system. This system is built into the Monport Onyx R and handles the internal operations of the laser. Now, to prepare engraving or cutting jobs on our computer, we need software similar to how slicers work in 3D printing. The Monport Onyx R comes with RD-Works, a free but somewhat cumbersome software. It's very capable, but its user interface feels outdated and isn't the most intuitive. I managed to complete some initial projects using RD-Works, based on information in the machine's user manual. However, like most in the field, I recommend upgrading to Lightburn eventually. While I still come back to RDWorks for one key readout, the Z coordinate after autofocus, which I haven't yet figured out in Lightburn. Lightburn is far more user-friendly overall. If anyone knows where to find the Z coordinate readout in Lightburn, please drop a comment below. I mention RDWorks first because Lightburn requires us to purchase the Pro version for a hefty $199, which can feel like a steep investment. However, if you already have a basic Lightburn license, it's only a $100 upgrade. But Monport also offers a Lightburn plus rotary bundle with this laser, and with my 10% discount code GERGO10, link in the description, you can essentially get Lightburn for free. Trust me, you'll want to make that upgrade. Lightburn is so much more convenient. I will dive deeper into setting up this software, specifically for the Onyx R in a follow-up video, including the somewhat convoluted camera setup process. Of course, after receiving the device, I ran a few engraving and cutting tests. What I discovered was that the Onyx R's autofocus is calibrated to focus 2-3 millimeters deep beneath the surface of the material, which is ideal for cutting. However, this setup caused it to be slightly out of focus when trying to engrave fine details on the surface. But this can easily be adjusted for our use case. With some trial and error, I found that setting the focus offset to 10 millimeter produced the sharpest engraving results. On the other hand, for cutting, it's best to lower the laser head manually by 3-4 millimeters closer to the part. While we can adjust the focus offset in the machine settings and try the modified values, unfortunately, with this KT332N controller, the Z offset control doesn't seem to work during cutting jobs. So our cutting will be a bit less efficient with the automatically acquired focus distance unless we adjust the Z distance before cutting on the move page, which is also not very difficult. I will walk you through this process in more detail in a future video. For now, let me walk you through a more simple project that will give you a taste not only of my favorite snack, but also how the Monport Onyx R can elevate our creativity. For this project, we'll make a gift box for some Danish crispy bread my family loves. I started by preparing a simple box using boxes.py. Don't worry, I've got the link in the description below. You can directly set it to export the format for Lightburn, and I went with a kerf value of 0.07. This gave me an extremely tight fit, almost too tight. So if you're using the Monport Onyx R like I am, I'd suggest keeping it at the default 0.09 millimeters. Now, this box doesn't come with the kind of lid I wanted. So in Lightburn, I added some grooves where the top can slide in. It's simple. Just add a few filled rectangles on the top of the 3 sides and cut the top part of the 4th side. That will give us a spot to slide the lid into place. For the graphics on the box, I got a little creative and used Dolly in ChatGPT to generate the designs. Lightburn makes it super easy to vectorize these and add some text in different fonts and sizes. I also resized the top lid to fit perfectly, considering the groove depth and the thickness of the plywood. You'll see 2 lid designs in the project. I'll be engraving both sides of the lid with the recipe etched into the underside. As for the cuts and layers, here's where things get interesting. For the grooves, I needed them to go about 1.5 millimeters deep, which is possible using 45% power at 100 millimeters per sec speed. For the graphics and text, I dialed the power down to 40%, but up the speed to 250 millimeters per second to keep it less deep, but still dark enough. I've also added 1 millimeter deep grips on the edges of the lid. Those needed 45% power again, but this time at 150 millimeters per sec. I got all of these values from my engraving tests that I did earlier. This laser is fully capable of cutting 4.3 millimeter plywood in a single pass. However, I found it better to do it in 2 quicker passes. Why? Because at slower speeds, the wood tends to catch on fire, and we also get less soot on the edges at higher speeds. So we set 2 passes using 70% power at 40 millimeters per second each. The user guide advises not to exceed 70% power to prolong the life of the laser. We are keeping it safe. Now the material goes into the device. The lid stays open nicely thanks to the telescoping arms, which work well, but my plywood sheets were slightly warped. So I designed and 3D printed these little pegs to pin down the material securely onto the honeycomb bed. They fit perfectly into the holes. Link to the STL files in the description right below the like button. A quick tip, the bed is actually larger than the 460 by 290 millimeter work surface, so it's best to position your material in the center, also for the clearest camera view. Even though the viewing window is supposed to block the laser's invisible light, I still follow the guide's advice and wear protective glasses. Unfortunately, the unit didn't come with any, but I found a pair on AliExpress with the OD6+ rating for the 10,600 nanometer wavelength from a reputable, dedicated laser supplier. I'll put the link to this exact product in the description too. Better safe than sorry. With the material set, turn the device on, we close the lid, and after a few seconds, it connects to Lightburn and the laser head homes automatically. We update the camera overlay using this button. If the button is grayed out, just switch to none and back to the camera to refresh it. Then it's time to arrange the pieces to make most of the material. I love having the camera and this ability. Next, we move the laser head to the center of the workspace and trigger the autofocus. Quick and easy. Before we start the job though, I have to manually switch on the duct fan. This is one feature I wish we could control directly from Lightburn. With the option Cut Selected Graphics enabled, I have to select the pieces which fit the material and hit Start. Under Edit Device Settings, I've configured a 3-second start and end delay to give the air assist pump and exhaust fan time to spin up. The layers are processed in order, starting with the engraving tasks and finishing with the cutting passes. Once the first round of cuts is done, having the frame pinned down, we can flip the engraved parts which need engraving on their backside as well. Conveniently, they are all symmetrical, which makes aligning them so much easier. After this, we can go ahead and cut the rest of the parts that didn't fit on the first sheet of plywood. No fancy shutdown command needed, we just turn off the machine once everything is done. And as for assembly, well, that 0.07 curve gave me such a tight fit, I didn't even need glue. If you want an easier assembly, you can set the curve value slightly higher to maybe 0.09, but then you will need to glue the tabs together. Sure, we could 3D print a box like this out of plastic on one of our bigger printers, but you gotta admit, a decorated wooden box like this has a completely different level of aesthetics. Plus, the material costs are lower and it takes way less time to finish. Now, don't get me wrong, I'm not against 3D printing and plastics at all. I just love being able to work with all these other materials too. In fact, combining the two techniques, as I've shown in these earlier videos, really opens up a lot of creative possibilities. So, how tempted are you to upgrade your workshop with laser cutting? At just under $2,000 with the coupon code GERGO10, the Monport Onyx R55 is, in my opinion, the best entry-level one-stop solution. It's packed with all the features you need for safe and efficient work: an enclosure, exhaust system, built-in camera, and autofocus. If you order it now, it will arrive just in time to help you create this year's Christmas gifts and decorations. I'll be following up with more information about setup, tips on usage, maintenance, and calibration. So subscribe to make sure you don't miss those videos. Plus, more content on 3D printing and laser working is on the way. I'm getting a new 3D printer soon. I'll leave you with a playlist of my other laser cutting videos and a project where we use both the laser cutter and my 3D printers together. Now, go print 3D. And as one of my favorite podcasters always says, another Gergo Print 3D video is in the can. Thanks for watching.